මොකක්ද ඔෆ් කරන්න මේ waiting room හරිද?
ඔව් අවුරුද්දේ මේ ස්ටේබල් කනෙක්ෂන් එක තියෙනවා. ස්ටේබල් නම් මේක තමයි කියලා. මේ වරුණ වාර දෙන්නද මේ
ඔව්
පොස්ට් එකම? එයා කතා කරගෙන යනවා ලයිව් ස්ට්‍රීම්.
මට එපා මට ඒක මේ ඔක්කොම කරන්න බෑනේ මේක ෂෙයා කරන්න ගමු. ඉස්සත් තියෙනවා. අන්සන මේ කාටර දෙන්න කාටද ළඟ ඉන්න කෙනට එයා මොකද කෝස් දෙන්න
Good evening, everyone. Welcome to CryptX 2.0 Hackathon Workshop series. We are pleased to have you all here today for today's session on designing the first architecture on AWS. As you prepare for the hackathon, understanding how to design scalable and efficient system architecture is essential. This session will guide you through the fundamentals of building your first architecture on AWS and help you approach problem solving with a structured, industry relevant mindset. I'm Amanda Tirimana and I will be moderating your session today. It's my pleasure to introduce our speaker. We are honored to have Mr. Shamir Dulanga, Engineering Manager and at Enlayer, an AWS Certified Solutions Architect Associate, and an AWS Community Builder. With strong expertise in cloud architecture and real world system design, he brings valuable insights into how efficiently can we build systems, structure solutions using AWS. Let's formally welcome our speaker to the session. Mr. Shamir Dulanga, over to you.
Thank you, Amandi. Okay, so I guess we are good to go, right? You can hear me?
Yes, we can hear you.
Perfect. So I will start by sharing my screen. Right, and I hope you can see my screen as well.
Yes, we can see the screen as well.
Right, right guys, so let's get started with this session. So today's session's topic is designing your first AWS architecture. So my plan was to present you a small problem that requires using set of AWS services. So when we say AWS services, there are more than 200 AWS services available. So when we are going to design an application with AWS, we need to pick several solutions, several services for the solution. So there can be multiple services that provide same and almost identical services. So we need to pick the best one for our architecture. So it's bit a difficult task because there is no exactly right answer for every time. So we have to weigh in what are the advantages, disadvantages, and our requirements when we are going to pick AWS service. So plan today for is I will present you with a small problem, and then I will say, okay, we can use these AWS services for them. So I will discuss about those services in detail, and I will show you how you can create it, such a services in AWS console. And finally, I will discuss a bit about infrastructure as code to give you an idea about how you can deploy these AWS services. So let's get started. So a little bit about myself first. So as Amandi mentioned, I'm Chamir Dulanga. So right now I am working as engineering manager at India and Accelero. So I started my professional path in 2021 at 99X. So last year I moved to a new adventure at India, and I'm AWS certified architect, and this is my 5th year serving as AWS community builder. So before getting into technical detail, I will quickly tell a little bit more about what is Enlia, because I think it's a new company for you guys as well. So yeah, Enlia, if you search Enlia in our website or anything, you will get it as a content marketing agency or content engineering. So Enlia is our content engineering wing, and our software engineering is known as Accelero. So we are working on 4 to 5 Norwegian projects at Accelero. So when we say Enlia, anything related to software engineering goes with our development arm, Accelero. So yeah. Yes, so at Enlia, we provide career paths for DevRel engineers and digital marketing. And at Accelero, our engineering, we provide career paths for software engineers. So that's a basic understanding of our company structure. Okay, now we can get into our session. So I will directly jump into the problem now I'm going to present for you guys. So our goal is to implement an AI-powered event feedback solution. So let's assume that there is an organization that plans event for various events. And right now they do not have a good way to get a feedback of how they organize the event or their organization. So our goal is to design an application that allows users to log in and upload their feedback as PDFs, videos, or audios, and process those inputs, save it in a database, and whenever the admin or the event organization company needs to access them, provide them access. So I will not be talking about any front-end implementation, so I will just focus on the back-end implementation with AWS services, right? Okay, so this is the basic overview of our system, the problem. So we need to implement a user sign up and login service. And then we need to allow users to upload their feedback files. And we need to obviously run the application logic and store this extracted data somewhere in a database. And there can be situations that we need to process this data synchronously and send email or SMS notifications for the users, whether mainly for the event management organization that this analysis has been completed. And we might need some AI tools or AI models to like extract the content from the PDFs or the audios that user upload, extract the exact content or summarize or generate reports. So I'll be briefly touching these services on the way in our session. Right. Okay, so this is the high level architecture of what we are going to do. So I will pick part by part from next slide onwards. So just for you to get an overview, we have user and they cannot log into the system using authentication service. And then we have S3 bucket where users can upload their feedback. And then we will be using Lambda functions to analyze this uploaded text using Bedrock or maybe extract or transcribe, and store the data in DynamoDB and inform the user using SNS. So I will go into each of these services in detail so you can get an idea. So if you have any questions along the way, you can drop it to the chat and I will answer after each service. So at the end of the session. Okay, right. Yes. So this is the flow again. So this is the one I described previously. So I will directly jump into the first service. So AWS Cognito is the AWS services that we use for application-based authentication. So there are several AWS services that related to authentication, like AWS IAM. Yeah, so I got a message saying like you understand better if it is taught in Sinhala. So I can do it in Sinhala totally, but is there anyone who cannot understand Sinhala if I switch to Sinhala? Varuna, Amandi, are you guys fine with that?
It's totally fine. I
Okay, now we have one that cannot understand Sinhala, so they mean I'll try to balance it between Sinhala and English so everyone is comfortable with it. Okay. Right. So yeah, AWS Cognito is the authentication service that we mainly use for application-based authentication. So there are several AWS services like AWS IAM, AWS Identity Management Center, which is known as AWS SSO previously, that we can use for various authentication purposes. But for an application, AWS Cognito is the go-to service. So why is that? AWS Cognito provides us several features that help us implement our applications with ease without any more customized implementation and spending time of doing anything. So the first feature that is provided by Cognito is something called user pools. So this is a group of users. So AWS, I will show it to in the console as well. So this is a group of users that can log into your application. So whether you are implementing a web application or a mobile application, you can use a one single user pool for both applications. So whenever a user sign ups, we put that user into a user group belongs to application. And if we are implementing authentication service manually without Cognito or any other service, we have to do this JWA token authentication part, handling part, encryption and all. But Cognito, it take care of everything and manage that for you. And also it supports federated login like Google, Facebook, Amazon by default. So you can only have the one line of code or just few button clicks through the console. And also you can control access level based on different roles. So if your application have several user roles like admin, manager, user, you can define several permission level for each user. And whenever a user sign up for your application based on the selection, you can assign that role. So then that new user will get the permissions that we defined to it. So if I do a comparison between traditional and Cognito, you can see these comparisons. So user management part, Cognito has built-in support. So if we are doing it manually, we have to come up with a custom logic for that. And for security, it's built-in security. AWS take care of it. And password handling, it's managed securely. We do not have to define any regexes or anything. It's just one line of code or few button clicks, that's all. And token management, AWS take care of you. Social logins, built-in support. But the customization, if you need much more customization, you have to go with the custom login implementation. So customization part, there is a bit limitation when it comes to Cognito because it's a managed service with some generic features. And also it has some, it support hosted UI. So if you need a login UI, you can just get the login UI provided by the Cognito. You don't have to wait until, you don't have to implement one yourself. And it's highly scalable. Okay, so now how it connect to our application. So as I mentioned, there are users that need to log into the system and submit feedback, and there are users who need to admin users that the owners or maybe admins of the event management company that need to look into those feedbacks. So we need to allow users to log in with their email, password, credentials, and then we need to authorize the request of those users when they are uploading their feedback or the admins retrieving their data. So that's how Cognito plugs into our system. So it's the first entry point of the system, right? So if we go to the architecture, so we have user and user directly logins to the system with Cognito. Okay, so right, so that's the basic part or the entry part of application. So අපි ගාව තියෙනවා AWS Cognito කියලා service එක. application එකට login වෙන්න හරි user කෙනෙක් sign up වෙද්දී හරි අපි use කරන්නේ Cognito. එතකොට අපේ application එකේ අපි ඒක use කරන්න හේතු තමයි Cognito කියන එක fully AWS managed service එකක්. අපිට JW token handling වගේ දේවල් ගැන හිතන්න ඕනේ නැහැ. Cognito use කරද්දී ඒ වගේම password handling වගේ දේවල් හරි easily online configuration එකක් වගේ තියෙන අපි code එක through කරනවා නම් ඊට පස්සේ SSO logins by default integrate කරලා තියෙනවා. ඒකත් just we have to click few things, that's all. So considering all, if we do not have any customization, extreme customization logic, we can stick with Cognito, right? So now I will go to the AWS Cognito console to you guys to show. So I hope at least some of you guys are familiar with AWS console, but so I'm not going to go into basics of the AWS. So AWS console, so I will go to services. So in Cognito, there are two options. This is the user pool I described, and there is something called identity pools. So user pool කියන්නේ අපි application එකට login වෙන register වෙන users ලා ඉන්න pool එකක්. So හැම application එකකටම එක user pool එකක් ගන්න තියෙනවා. And identity pools, that's another type of user group, but this is used to access the AWS services internally. So a user need to access the AWS service. We use our access token generated by the user pool, and AWS provide us this identity access token that we can access services. So That's something extra. So if you go to AWS user pool, so this is a user pool that I have created for this demo. So in Apple clients, you can see what are the applications that are connected to this user pool. So right now I only have a one application client. So likewise, if you need, you can create several application clients. So single page application, mobile application or anything. So for one user pool, you can connect multiple applications, right? And the users. So right now there is only one user. So my user, we can create users through here as well for our user pool. So application එකට user කෙනෙක් add කරන්න ඕන sign up වෙන්න ඕනකම් ඕනත් නෑ අපිට ඕන console එකෙන් add කරන්නත් පුළුවන්. So that's the way of we are doing manually. In application we do it through code, right? And next we have this user groups. So right now I do not have any groups, but if our application has several roles, I can create those one group per each role and already assign permissions beforehand. So මට කලින්ම පුළුවන් permission assign කරලා තියන්න. So මම user කෙනෙක් create කරනකොට මට පුළුවන් මේ group එකට user assign කරන්න. එතකොට ඒ user ට තියෙනවා අදාළ role එකේ permission, right? And then the authentication methods. So you can log in with emails, SMS, and password policy. So you can see here by default the password should be 8 characters and password requirements one number, one uppercase letter, one lowercase letter. We can customize it from here as well. So we do not have to write any regexes or validations in the code. We just have to define these configurations and Cognito will take care of that. And then sign up options, the multi-factor authentication, device tracking. So there are a lot of features that by default supports it. And yeah, sign up and social login. So if I click here, you can see that it by default support Facebook, Google, Amazon, SAML, Apple sign in and OpenID. So you just have to do few small configurations. So client ID, client secret, just few input fields and add identity provider. So your user pool will get connected to this identity provider and you can use Google login or Facebook login to log into your application. Yeah, so there are a lot of security features as well. I will not go into in detail. So yeah, that's about Cognito, and that's why we are using Cognito when it comes to implementing an application with AWS. So it's easy to use it. So, and a lot of things are managed by AWS, scalability, security, and a lot of basic features. So that's why we will use Cognito in our application. So do you guys have any questions related to Cognito? So, you can drop it in the chat and I will answer it after covering few other services as well then. Right. Okay, let us continue with the presentation there. Yeah, so now we have only two user have and we have user and we have the Cognito. Okay. Right. Next, the API gateway. Right. So API gateway is the managed service that allow you to create APIs through the in AWS. So there are two options. If you are using REST APIs, so I think that's the most common thing you have heard of. API gateway is the option. And if you are using GraphQL to access your data, you have to use AppSync. So those are the two services supported by AWS based on the approach you are going with. So if you are going with REST API, you have to use the API gateway to create your APIs. And if you are using GraphQL, there is another service called AppSync. So since the most familiar one is REST APIs, I guess for you guys, so I have chosen API gate for this application, right? So similar to Cognito, this is also a fully managed service and integrates easily with Cognito. So we do not have to do any custom or additional implementations. And it integrates easily with all the AWS services. And it has limitation for throttle and rate limiting. So if anyone tries to exploit your system by any DDoS attack or anything, these applicable rates, these limitations will be automatically applied. And monitoring and logging through AWS CloudWatch, and it's highly scalable. So API gateway කියන්නේ අපි REST API වලින් වැඩ කරනවා නම් අපේ application එක AWS ලගේ service එක අපි use කරන්න ඕන. මේකත් highly scalable service එකක්. ඒක connect වෙනවා Cognitoත් එක්ක සෑහෙන ලේසියෙන්ම and other AWS services. So අපිට කරන්න දෙන දේවල් minimum. So මේක ස්කේල් වෙනවා, රේට් ලිමිට් තියෙනවා. ඒ කියන්නේ අපිට ඇප්ලිකේෂන් එක කවුරු හරි එක්ස්ප්ලොයිට් කරන්න හදනවා නම් එකපාරට රික්වෙස්ට් ගොඩක් එවලා මේ ලිමිට් ඔටෝමැටිකලි ඇප්ලිකබල් වෙනවා and අපිට errors and log monitor කරන්න පුළුවන් easily cloud.check එක. So ඔය වගේ දේවල් නිසා තමයි AWS API gateway එක අපි use කරන්නේ. Right? So අපි බලමු අපේ application එකට කොහොමද මේ gateway එක connect වෙන්නේ කියලා. Right? So now previously we talked about Cognito. So whenever a user logs into the system, we first direct them to Cognito, and then user enters his email, password, and then Cognito authorizes if this is a valid user or not, and return a token. And afterwards, we can use that token to access any APIs in our application. For that, we will be using this API gateway, right? It receives the request, and then again it verifies our JWT token by connecting to Cognito, and it is a valid request. We allow user to proceed. If it is not valid, we are not allowing user to proceed, right? So here is how things are done. So after the Cognito, there is like 2 arrows missing here, so I did not include them intentionally. So user sign in with Cognito and they get the authentication token, and afterwards they try to access our application. So the request will go through API gateway, and if it is a valid request, user can proceed to further, and if it is not valid, user will be redirected back. So basically in our application, we are using API gateway to route the users HTTP request to relevant resource. So behind the API gateway, there can be several lambdas with different purposes. So API gateway knows which lambda to call. So based on our request, it will call the necessary lambda. It's like a controller calling the controllers in your application if we take an Node.js application. So there is a one file that handles all things. You define routes and all. Based on your request, it selects which controller to call. So API gateway is doing something like that, a job, right? So now we have 3 authentication part and how the user will going to access our other AWS services. That part covered, right? Next, I will go to some more important part of this our application design. And in AWS as well, I think these next 2 services are 2 of the most important services that anyone should get familiar when they are doing AWS, right? So when AWS, there are multiple computing services. So AWS has computing services several, like there are 4 to 5 services in computing. But EC2 and Lambda are the 2 most popular and most used services out of them. And I think Lambda is one of the most popular services even among anyone who's not familiar with AWS. They should know what is Lambda. So AWS Lambda කියන්නේ 2015 වගේ introduce කරපු සෑහෙන පරණ but සෑහෙන popular service එකක්. So next I will talk about those 2 services and which one I am going to select for our application architecture, right? So EC2, it's a virtual server. Basically, if we take application that's run locally. So I think almost everyone here has run application locally, right? හැමෝම වගේ locally application එකක් run කරලා තියෙනවනේ. අපි එතකොට local host එකේ application එකක් run කරද්දී අපේ machine එකේ තමයි අපි run කරන්නේ. එතකොට අන්න ඒ වගේම machine එකක් තමයි EC2 instance එකක් කියලා කියන්නේ, right? So අපි machine එකක් ගනිද්දී අපි මොකද බලන්නේ? අපි බලනවා මේකේ OS එක. Then what is the RAM and what is the VGA, what is the memory, what is the processor. So අපි ඔය වගේ දේවල් ගොඩක් බලන machine එකක් select කරගන්නේ. අන්න ඒ වගේම same machine එකක් තමයි EC2 instance එකක් කියන්නේ. AWS ලගේ servers වල තමයි මේ run වෙන instance එක run වෙන්නේ. අපි application එක අපේ local device එකේ වෙනුවට ඒ application එක run කරනවා, ඒ instance එක run කරනවා. එතකොට ඕන කෙනෙක්ට පුළුවන් මේක access කරන්න globally. So we run our application in their AWS instance. So anyone global can access the application. So that's the main difference. You can understand how EC2 instance works. So the features, like key features we need to be aware of is like EC2 instance, you have the full control. So you can select the AMI, OS, memory size and all. And even if you need, you can install custom softwares that require for your application. So අපේ local environment එකක් setup කරද්දී අපි Node.js, Git ඔය වගේ දේවල් install කරනවානේ. EC2 instance එකක අපිට පුළුවන් ඕනනම් instance එක create වෙද්දිම ඔය වගේ දේවල් install වෙලා ඉන්න කියලා දෙන්න අපේ application එකට ඕන දේවල්. ඊළඟට there are different instance types. So if you are doing a web application implementation, there is a specific type. And if you are doing something like machine learning or training models, there is a specific type optimized for that one. And if you are doing something memory intensive, there is a special instance type optimized for that. And the scaling, there are several options to scale the application's logic and also the pricing models. So there are flexible pricing models for use. So now I will go into the AWS console and come back here to discuss this point for you. Okay. So next, yeah. So here is the EC2 service. So Elastic Computing. And I will click here to create a new instance. So just put a name here. And next, you can select what is the OS you like. So it supports Amazon Linux, Mac OS, Ubuntu, Windows, Red Hat, Debian. So I will just select here Windows, and the OS is Windows now. And then we have something called AMI, Amazon Machine Image. So this is what install like the basic softwares that require to run this EC2 instance. So there are various options, like we can select it. All these are available for free tier as well. And if we need to implement something custom, like as I said, so if our application need a specific dependency or something, we can create the AMI in the AWS marketplace and use that AMI whenever we create a EC2 instance as well. So that's the customization option we have. And afterward, we have to select the instant type. So here we have to think like what is the CPU cores we need and what is the memory we need. And higher the memory and the cost is high. So if we take this T2, T3 Nano, it's only 512 megabytes and 2 cores. And we selected Windows. So Windows base price is 0.0112. But if we go for a bit higher, like this 16 GB one, and it's 0.72. So it's increased like high significantly. So the cost of the EC2 instance depend on the OS we use and the size of the instance we are selecting, right? For our instance, I will just click this just small one, V3 micro. And then this network services as well. So I will not go into details. So we can keep them as it is. We do not have a specific requirement. And then, yeah, we have to select the hard of the EC2 instance. So right now it's 30 GB general purpose SSD. So we also have provisioned IOPS SSDs as well. So these are a bit high costly, but they are optimized for input and output. So I will keep them as it is. And I click this launch instance button. Creating the So it will take some time to up the instance. So I will go to instance list. So now this is up and running, and it's still initializing. So as soon as I click that create launch button, AWS has started costing me for my EC2 instance. So they do not care whether I use my application or my instance or not. As soon as I create it, I am starting to cost it. So අපි EC2 instance එක අපේ application එකට use කරත් නැතත් අපි instance එක start කරපු වෙලාවෙ ඉඳන් end කරනකම් අපිට ඒ cost එක pay කරන්න වෙනවා. Right? ඒක තමයි EC2 costing model එක. So now I will go back to the presentation. So these are the things I showed you. So how we can select an OS and a custom machine image and hard disk size and the processor size and all. And I mentioned that there are several purpose instance types. So for the web application, web development, general purpose is more than enough. So if you have any other specific requirements, you can go with these 4 service types, right? And the next one is scaling options. So EC2 Pro is not by default scalable. There are scaling options that we need to configure. So configuration option ටිකක් තියෙනවා. අපි ඒව define කරන්න ඕන. So manual, dynamic, predictive and schedule. For this, I will take an example that yesterday we got released the A-level results, right? So in my time, it was not easy to check A-level result whenever the result got released. So we have to keep trying several times for that. I think you had the same, I guess you had the same experience. So that because that website is not hosted, I don't know whether they have changed it, but at that time it was not hosted in a scalable service. So if I am the administrator of that system, if I know that we are going to release some results or anything tomorrow, I can either manually scale by adding another instance. So TN instance එකක නම් මම ඒ වගේ තව instance එකක් හදලා load balance එකකින් load එක balance කරනවා instance දෙක අතරේ. So that's manual. And in dynamic scaling, we can define rules. So if the usage of our EC2 instance is going beyond 80% utilization, I am spinning up another service. So now there are 2 and the load will go down. And if the load of the both instance go below 20%, I am shutting down one instance and sticking with one. So it will have moderate usage again. And the predictive is using the machine learning of the previous data to scale up and scale down. And this is schedule based. We can create a schedule to scale and scale down. So by default, EC2 is not scale automatically scaling. We have to define either of these options if we are going to scale our EC2 instance, right? Yes, for EC2, we have to configure load balancing for anything. I got a question from someone asking we need to load balance for dynamic scaling as well. Yes, because it's different resources, we have to use a load balance. And the pricing. So previously I showed you when I'm creating the application that it is like something called 0.012. So that's the on-demand pricing. So that's the most common pricing option that you have to pay for what you use. But out of these options, so it is the most costliest one, but you only have to pay for at the moment you start your EC2 instance and at the end of your EC2 instance, right? And the second that highly used one is reserved instances. So companies that know exactly their application will run for this limit, this time period, they can opt in for this. So this is like up to 75 cheaper than on demand, but you have to commit for either 1 year or 3 years. එක අවුරුද්දකට හරි අවුරුදු 3කට හරි තමයි අපි reserved instance එකක් ගන්නවා නම් ගන්න ඕන. අපිට මේකෙත් පුළුවන් upfront pay කරන්න. කියන්නේ අපි instance එක අද buy කරනවා නම් අද full payment එක කරන්න පුළුවන්. එහෙම කරොත් සෑහෙන ලොකු discount එකක් හම්බ වෙනවා. අපි අවුරුදු ඉවර වෙලා කරොත් ලම්බෙන discount එක අඩු වෙනවා. So reserved එකක් ගන්නවා නම් 1 year or 3 year ගන්න ඕන. ඒකත් upfront pay කරනවා නම් අපිට ලැබෙන discount එක 75 වගේ discount එකක් ගන්න පුළුවන්. Saving plan is also something similar to that. And dedicated host and dedicated instance. Some companies can have requirements that they need to host our services in a dedicated physical server or dedicated hardware. So in that case, we can choose one of these 2 as well. But if you are hosting an application for normal web application usage, I think the go-to one be on-demand instance. But you can reduce the cost of a on-demand instance by combining it with some spot instances as well. So on-demand price එක වැඩි, but අවුරුද්දක commitment එකකුත් නැත්නම් reserved instance එකට යන්නත් ලොකු තේරුමක් නැහැ. අපි cost එක compare කරලා බැලුවොත් ඒ වගේ වෙලාවට වඩා පුළුවන් එක on-demand instance එකක් එක්ක spot instances ගොඩක් use කරන්න. Spot instance එක on-demand එක compare කරලා බලනවා 90% වගේ cost එකේ අඩුවක් තියෙනවා. ඒ කියන්නේ on-demand එක per dollar එකයි නම් spot එකක් per dollar 0.1ක් වගේ වුණත් වෙන්න පුළුවන්. So කොහොමද මෙච්චර අඩුවට මොකද්ද මේ spot instance කියලා කියන්නේ එතකොට. And if we take AWS region, there is allocated computing capacity for that region, right? But not the fully capacity is used every time. So region එකක තියෙනවා මොකක් හරි computing resources ටිකක් AWS ලගේ servers වල. හැබැයි හැමතිස්සෙම ඔය full capacity එකම use වෙන්නේ නැහනේ. එතකොට ඕකේ තියෙනවා free capacity එක discounted price එකකට AWS ට sell කරනවා. එතකොට ඒ වෙලාවේ තියෙන demand එක අනුව spot instance වල price එක up down වෙනවා fluctuate වෙනවා. අපිට පුළුවන් spot instance එකක් ගනිද්දි කියන්න අපි පැයකට ඔන්න අපි කිතමු $0.5ක් අපි pay කරනවා spot instance එකක් buy කරන්න. So we are paying 0.5 dollars per hour to get our spot instance. And if the spot instance price of that region is below than 0.5, we can use spot instance without any issue. But when the demand increases for the computing resources in that region, AWS will increase the price of the spot region. So once it is above $0.5, our instance will be shut down automatically with 2-minute notice. So that's why spot instance alone is not suitable for application. මේක මෙච්චර ඩිස්කවුන්ට් එකක් තිබ්බට අපිට ස්පොට් ඉන්ස්ටන්ස් එකකින් විතරක් ඇප්ලිකේෂන් එකක් රන් කරන්න අමාරුයි. හැබැයි අපිට one on demand එකක් එක්ක multiple spot instance දාලා scalability handle කරලා run කරන්න පුළුවන් low cost එකෙන් on demand ඒවා දෙකක් use කරනවට වඩා. So those are some decisions that you need to take when designing an architecture. So you need to think about performance, you need to think about cost and decide what is the best option for you. So that's why I said there is no 100% correct answer for when designing an application, right? Okay, now I will go to AWS Lambda. So after talking about Lambda, I will compare these two again. Also, when I talk about Lambda, you will see that there are some things, the EC2 is not good and the Lambda is not good. And I will then say why I selected Lambda in our service. Okay, right. So in AWS Lambda, this is one of the most popular AWS services. So it's now more than 16 years with the service introduced. Yeah, I will start with some key features. So give me 1 minute. Yeah, okay. So Lambda is an event-driven service. So which means we can trigger a Lambda function based on an event. So event is like uploading a file to a S3 bucket or processing a message from a queue or a request coming through API gateway or AppSync or a notification. So Lambda will start based on that trigger, complete its task, and it will shut down. And Lambda is automatically scalable. So like unlike EC2, we do not have to think about how we are going to scale. So it's highly scalable. You can handle number of millions of requests at once. And you will only have to pay for what you use. So EC2, you will have to pay from the moment you start and for the moment you end. But Lambda, you will only have to pay for the moment, for the duration you are using the application. So EC2 එක Lambda එක අතරින් ප්‍රධාන වෙනස්කම් දෙකක් තමයි මේ දෙක. Lambda එක scalable, automatically scalable and pay කරන්න ඕන අපි use කරන වෙලාවට විතරයි. මම Lambda එකක් දැන් හැදුවා කියලා ඒ Lambda එක use වෙන්නේ නැත්නම් මට cost වෙන්නේ නැහැ Lambda එක. Right? Scaling කිව්වොත් මේක අපි කියන automatically scalable කියලා, but AWS account එකකට තියෙනවා Lambda provision limit එකක්. ඒ කියන්නේ අපිට එකපාර Lambda කොච්චරක් run කරන්න පුළුවන්ද කියලා account level limit එකක් තියෙනවා. අන්න ඒ hard limit, ඒ limit එක hit වෙන්න පුළුවන්, but other than that we do not have to think about scalability at all. So if you get 1000 requests at once, Lambda will handle that, right? And features කිව්වොත් Lambda is stateless. එක support කරනවා Node.js, Python, Java, C#, Go on a runtime එකකට. And we can easily integrate it with other AWS services. Yes, pricing much cheaper than EC2 instance. So for example, it's only 0.2 per million requests. So that's a lot of requests. So this is very cost effective. Right. So now I will go back to the AWS console and show you guys how we can create a Lambda function. So I will create here to create a new function. So I will create one by default. from scratch. Let's put, yeah, you. Then runtime, here I have selected Node.js. You can either use Python, Ruby, Java, any supported one. And since I have using Node.js, I can select architecture, ARMO 64-bit architecture. There are some additional security configurations, but I'm not going to change anything. And just create. So compared to, okay, I have one same. So in EC2, we have to select the OS, memory size, and also here we are not going to select any of these. We can just select the runtime and create the Lambda function. It will take a couple of minutes, not couple of minutes, few seconds. Yeah, so now our Lambda function is here. So you can either write that code in this editor yourself, or if we are using like something like infrastructure as code, you can do it in your code. And once it is uploaded or deployed, you will see your code here. So right now there is a to-do implementation. Let's see. We have this 200 hello from Lambda, and we are returning that response. That's a very basic code we have. And there are some configuration settings what we did earlier. And now I will show you like how to test this application. So we can trigger this Lambda function through API gateway or app sync or S3 bucket events. Like if you upload something to S3 bucket, you can trigger Lambda function. So for example, common example would be generating thumbnails. So when we upload a profile image or something to application, most applications create a thumbnail, a lower quality version to show it in your application. So they can load the images faster. So what we usually do is we upload that image to S3 bucket, and as soon as the new object is added to the S3 bucket, we are triggering a Lambda function that will convert the image into a thumbnail. That's how this event-driven architecture works. And similarly, SNS, SQS, Lambda supports both of these. So right now I will just add it to test event. Basically, I don't need to put any input values here because our Lambda does not expect anything. So we have a hard code message and we'll show here. And you can see the status 200 and hello from Lambda. So that's what I have coded here. So basically, this is something like a function you write in your application itself. So you can write the code to access the database, process the data, and return that data here. And through API gateway, we can call that function, and it will give you the result you need to the front end. So basically, like one function you write in your application. You can either go with one function, one Lambda for one function, or you can write multiple functions in one Lambda. That's the architecture decision you have to make, right? Okay, now let's go back here. And with the things I explained, like I said, it's highly scalable and it is low cost and all. So now you might be thinking, the Lambda should be best with compared to EC2, right? So Lambda highly scalable cost එකට අඩුයි ඔක්කොම නෑ Lambda හොඳ වෙන්න ඕනේ EC2 එකට වඩා කියලා දැන් හිතනවා ඇති. Yes, there are some situations that is true. So for example, we don't have to think about OS patching capacity or instance maintenance. Unlike, and it is automatically scalable. You have to only pay for what you when the code runs, and it's event driven. So in these situations, Lambda is very good. But there are a few limitations in Lambda that we might need to go with EC2 instances. So, there can be applications that require more control over the OS that need you to run, and or there may be memory requirements. So in such situations, you have to go with EC2. And Lambda is only so you can only run one Lambda functions up to 15 minutes per one run. විනාඩි 15කට වඩා අපිට Lambda function එකක් එක දිගට run කරන්න බෑ. So if you have any requirement like that, you have to go with EC2 or other service. We cannot use Lambda. Lambda එකක් විනාඩි 15කට වඩා එකපාරක් run කරන්න බෑ. And Lambda is stateless. So if you have any state requirement to maintain state, you have to go with EC2 instance. And Lambda is more suitable for something that do not have predictable workload. So since we only pay for when the application is in use, it's perfect because if we don't know what will traffic will happen, it's no use of keep paying EC2 instance. So අපි දන්නේ නැත්නම් කොහොමද කියලා අපේ application එකේ load එක අපි සමහර ලාවට ඕනවට වඩා ලොකු EC2 instance එකක් provision කරලා ලොකු payment එකක් දෙන්න පුළුවන් අපේ load එක අඩු වෙන. සමහර ලාවට අපිට පුළුවන් load එක අපි හිතනවට වඩා අඩු වෙනවනම් අපේ resources overwhelm වෙන්න පුළුවන්. application එකේ users ලාට not responding වෙන්න පුළුවන්. So අපි එහෙම අපි හරියට predict කරන්න බැරි නම් lambda function වලින් application එකක් හදුවොත් user load එක මොකක් වුණත් scale up down වෙලා application එක වැඩ කරනවා. Right? So අපේ solution එක ගත්තොත් අපි lambda function එකක් select කරගන්න දේවල් හේතු කිහිපයක් තියෙනවා. So the one of the main reason is our application does not have anything that runs beyond 15 minutes and it has an unpredictable workload. So when there is an event, users might submit, and if there is no event, users might not submit any feedback. So event එකක් කර තිබ්බම තමයි අපේ application එකට user load එක වැඩි වෙන්නේ. So ඒක unpredictable. අපිට කියන්න බෑ මොන වෙලාවෙ load එක වැඩි වෙයිද අඩු වෙයිද. Then we have this uploading feature. අපි users ලාට දෙනවා feedback upload කරන්න image විදිහට හරි audio විදිහට හරි text PDF විදිහට හරි. එතකොට අපිට පුළුවන් මේ upload එකක් වුණ ගමන් අපේ lambda එක run කරන්න. By default lambda එක event driven නිසා. So that are the two main reasons we are going to use lambda function in our architecture. Right. So අපේ application එකේ lambda function එක අපි use කරනවා. එතකොට අපිට අපි මේකෙන් ප්‍රධාන වශයෙන් කරන්න බලාපොරොත්තු වෙන්නේ S3 මොකක් හරි ෆයිල් එකක් අප්ලෝඩ් කරාම ඒ ෆයිල් එක ඇනලයිස් කරන පාර්ට් එක bedrock call කරනවා නම් call කරන එක DynamoDB එකට save කරන එක user මොකක් හරි data එකක් ගත්තොත් ඒ data එක return කරන එක මෙන්න මේ ඔක්කොම දේවල් වලට අපි lambda function එක තමයි use කරන්නේ. මගේ initial architecture එක මේ තියෙන මෙතන අපහු ඒ photo එක අපි දැන් discuss කරලා තියෙන level එකට user authenticate වෙනවා. ඊට පස්සේ ඒ token එක use කරලා API gate එක through request එකක් යවනවා lambda function එකට. මේක වෙන්න පුළුවන් user අපි normal user flow එක ගත්තොත් මේක වෙන්න පුළුවන් ඕන user ගේ profile detail ඉල්ලන call එකක් වෙන්න පුළුවන්. නැත්නම් event company එකේ කට්ටිය එයාලට submit කරපු event details බලන call එකක් වෙන්න පුළුවන්. ඒක lambda function එකට ආවම lambda function එක අදාළ අනිත් service තියෙනවා call කරලා හරි මොකක් හරි processing ටිකක් තියෙනවා process කරලා හරි user ට ආපහු request එක දෙනවා. This is one flow. Next I will talk about S3 and then I will show you how we call the application lambda through S3 as well. So මේ flow එක user trigger කරන flow එක. ඒ වගේම අපිට පුළුවන් lambda function එකක් trigger කරන්න S3 හරි SNS through හරි මොකක් කරුණාම user ගේ flow එකකින් එන්නේ නැතුව අපිට පුළුවන් ඒක through lambda එක call කරන්න. So අපේ එහෙම situation එකක් තියෙනවා අපි image audio video files upload කරන්න දෙන නිසා. So that's why we are choosing a lambda function, right? Okay guys, do you have any questions related to lambda or EC2 instance? All right, so seems all good. So next service is AWS S3, right? So in our application, I repeatedly said a couple of times earlier as well, we have this feature that allows users to upload images and the feedback in various ways. So those are objects. So we cannot save these objects in a traditional database. For that, we have to use an object storage. So S3 is the most widely used and very cheap object store options provided by the AWS, right? Apit object images, video files, audio files, PDF, Word docs, so හැම එකම store කරන්න පුළුවන් S3 bucket එකේ. ඒකේ object store එක. Right? එතකොට මේකත් ඇවිල්ලා popular මේ AWS service එකක්. So අපි features ගැන කතා කරොත් මේක highly durable and highly available. We call it like 11 nines durability. So if we put something here, it will not get like almost never it will get lost. Okay, upload කරොත් අනිවාර්යෙන් ඔයාලට ඒක හොයාගන්න පුළුවන්. And they ensure 99.99 availability. ඕනම වෙලාවක මේක access කරන්නත් පුළුවන් ෆයිල් එකේ තියෙනවා. So one of the most stable services in AWS, which is S3, right? And ඒ වගේ මේක support කරනවා web hosting, so you can easily host a web application using S3, and you can version the same application, and there is by default security options provided by AWS, and there is different storage classes for different users. So I will discuss bit detail in the next slide. And there are life cycle policies as well. So life cycle policy එකක් කියන්නේ අපි මේක ස්ටෝර් කරන ඔබ්ජෙක්ට්ස් සමහර වෙලාවට අපි මාසයක් විතරද වගේ යූස් කරන්න පුළුවන්. හැබැයි කල්යද්දී අපිට යූස් නොකරනවා වෙන්න පුළුවන් ටිකෙට් ටික. For example, audit logs, user logs වගේ දේවල් අපි ගොඩක් කල් ස්ටෝර් කරලා තියාගන්න දේවල් වෙන්න පුළුවන්. Right? So ඒ වගේ දේවල් අවස්ථාවලදී අපිට පුළුවන් මේ life cycle policy එකක් යූස් කරන්න. අපි ලේසියෙන් access කරන කාල සීමාව තුලදී මේවා අපි යූස් කරනවා ස්ටෑන්ඩඩ් හරි frequent access S3 bucket එකක. login අපි මේක log කාලයක් ස්ටෝර් කරලා තියාගන්න නම් අවුරුදු 2-3ක් audit compliance requirements වලට අපි ටික කාලයකට පස්සේ move කරනවා glacier storage වගේ low cost storage එකකට. right? ඔන්න වගේ දේ තමයි life cycle policies කියලා කියන්නේ. So ඒක combine වෙනවා මේ storage class එක, which I will discuss next. So S3 standard is the most widely used one in web application. So widely used S3 bucket type එක. ඒක මම කලින් කිව්වා වගේ 11 nines durable and highly available. හැබැයි මේක තමයි සාමාන්‍යයෙන් cost එක වැඩිම storage option එක වෙන්නේ. But it is cheap compared to most of the services, right? And next we have option called intelligent tiering. So if we consider the AWS S3 bucket literally as a bucket, අපි bucket එකක් කියලා මේක හිතුවොත් මේක intelligent tier එකේ වෙන්නේ files that we access frequently, they will be storage on top of the bucket. So we can access those files quickly, and the accessing cost is cheap. And if we do not access that file, it will be stored bottom of the bucket, and it will take some time longer compared to upper level file we are accessing. So S3 intelligently changes the way orders those files in the intelligent tiering. And next one is standard infrequent access and once on infrequent access. So both of these are recommended for storing files that we do not access frequently, like on a daily basis or something like that. So since this is infrequent access, it's also provides 11 nines durability, but its availability is 99.9. So not 99.99. So the availability is a bit lower compared to the standard one. And this one zone means it will be only hosted in a one AWS availability zone. So it's 99.5. And next we have several glacier storage. So these storage are recommended for storing these files for long period of time. So common examples are like something like access logs, the data we save for audit and compliance requirement for regulations, for things like that. These storage options are much cheaper compared to standard, but it takes a lot of time to access data compared to standard one. So this Glacier instant retrieval, it provides millisecond access, but it's recommended to store the data that we usually access like quarterly. So store කරන එකේ cost එක අඩුයි, but අපි මේ type of storages frequently access කරන්න ගත්තොත් access කරන්න යන cost එක වැඩි අපිට. ඒක නිසා මේක recommend කරන්නේ නිකන් quarterly වගේ access කරන මොනවා reporting data ඒ වගේ දේවල් save කරලා තියාගන්න මේක recommend කරනවා. Next, Glacier flexible retrieval and Glacier deep archive. So අපි මේ වගේ storage එකක් select කරොත් අපිට data ටික retrieve වෙලා ඉන්නම සාමාන්‍යයෙන් පැයක් වගේ වුණත් යන්න පුළුවන්. And deep archive දැම්මොත් අනිවාර්යෙන් more than hour යනවා මේ data එක retrieve වෙලා අපිට එන්න. So ඒක නිසා අපි මේ වගේ storage වලට යන්න ඕන අපි අවුරුද්දට පාරක් අවුරුද්දට once or twice year වගේ save කරලා store කරන data access කරන තමයි මේ වගේ option වලට යන්න. But මේක cheap. So අපි ලොකු audit data හරි මොකක් හරි මේ වගේ details ටිකක් standard එකේ තියාගන්නට වඩා deep archive හරි මේ වගේ glacier storage එකට යන එක අපිට much cheaper, but we cannot access it too frequently like we are accessing profile images in S3 bucket. right? Okay, now let's go to the console. I saw your question, Kaushal. I will get back to you after this section. Okay. Right. Now let's see S3. Yeah, you can see there are a lot of SML buckets I have. So I just go inside one. So you can upload any file here and it will upload within few seconds here. So I will show you how to create a bucket. So you can select the S3 service from here. This is the service, and then you can click the create button option and you will get to a screen like this. So there are two types of buckets. So general purpose one is more than enough for application that you design or any general web application. And you have to install the enter the bucket name here. So up to like last few weeks, this bucket name was globally unique. So if someone has created the bucket name my bucket, uh, none of the other ones can create that bucket. But now this is region and account scope, so there can be buckets with different names in different same name in different account. So it should not be bucket like that. And there are some access control limitations you can enable. So it's disabled right now. And by default, bucket public access is denied in a S3 bucket. So anything you upload here, you have to explicitly allow from here that public or someone can access the content of the bucket. So there are different rules you can require here. So by default, this will be clicked. So there will be no public access to your bucket, right? And the versioning option, so you can either disable or enable it and just create the bucket. So that's it. Now you will have a object store and you can save anything in the sense files, video files, audio files, PDF, docs, anything. So in our architecture, this AWS S3 connects like this. So users can upload PDF, image, or audio files as their feedback. So we securely store these files in our S3 bucket, and once a file is uploaded, we trigger our analyze lambda that reads the content of the file using AWS services. So it can proceed with storing data in the database. So in the architecture image, our S3 bucket resides here. So user login වෙනවා cognito වලින් DW token එක ගෙනවා user token එක අපිට ඒ token එක use කරලා directly allow කරන්න පුළුවන් user front end එක through S3 bucket එකට file upload කරන්න. එතකොට file එක upload කරපු ගමන් this is we can create trigger another lambda function to analyze that content of that uploaded resource. So front end එකේ user පුළුවන් S3 එකට file එකක් upload කරන්න. upload කරපු ගමන් අපිට පුළුවන් තව lambda function එකකින් මේ content එක process කරන්න පටන් ගන්න. So that's the reason I have selected S3 and lambda, so we can easily integrate those two, right? Okay. Okay, so before moving into, I have a question. Let me read it. So I have a question. If we have a large level application and if we have different and lot of functions, do we need to take several AWS lambdas for each function? And is this good for a large scale application? So I will break down this question into multiple parts. So lambda is suitable for application in any scale. Either it's a large scale or a small scale, it's you can use lambda. So for example, the several projects that I am overlooking, they are like production grade applications. So we use AWS Lambda in any of these applications, right? So the decision of selecting, writing a one requirement or the one, maybe I will take a basic example here. So if we take a data model, there is like, the CRUD operations like create, read, delete, update. So it's your decision, like if you can either write one lambda function to create, let's take a feedback here. So create feedback and one lambda function to update, one lambda function to delete likewise. Or either you can combine all four options in a one lambda function and use that. So it's basically architecture decision, but usually what I do recommend is I do not recommend to break that lambda function into that small functionality. So maybe a feedback. So one lambda that is responsible for handling feedback. So one lambda function that is responsible for handling authorization or anything. So one lambda function to handling for email notifications and all. So likewise, you can divide it anywhere you like, but do not go into very much fine-tune level. So always try to keep it in the middle. Right. If you have any questions, Kaushal, put it in the chat. I will take it even after the session as well. Right. Okay. Now, if I go back to the architecture diagram again, we have user and user is authenticated, and user can access our Lambda function and upload files to S3. Right. Now we should have some service to store this data. User upload කරපු file එකෙන් extract කරපු data අපි save කරලා තියාගන්න ඕන event company එකට ඕනනම් බලන්න. For that, we need to have a database, right? In AWS, there are two database options. One is RDS, and that's the relational database service, and the second most popular one is DynamoDB. So that's the NoSQL option. So first, I will quickly talk about the RDS, but for our application, I have selected DynamoDB, right? Okay. So if I think most of you guys are familiar with the relational database, right? So when we take, say, RDS, that's Amazon Relational Database Service. So within that, you can go with MySQL, MariaDB, Oracle. There are like 6-7 options. Aurora, you can select it. So it supports relational data modeling, ACID transactions, and multi-availability zone deployments, read replicas, and automated backups. So almost it supports all the features that you require for a database, right? So automated backup means there are options like point-in-time recovery. So if you enable it, you can revert to a database in any point up in last 35 days. Also, you can create manual backups periodically as well. So if something happens, you can restore your database. And this multi-Asia availability zone deployment, if we take a AWS region, there is at least minimum of 2 and maximum of 6 availability zones. So you can deploy your database in multiple availability zones. So if one zone goes down, the application will use the instance in the other zone. And read replicas. So if you use a one instance to write and read, when there is a lot of reads happening in an application, the application can get throttled. So to avoid that, you can have a special dedicated instance for reading the data and while keeping one for the writing. So application එක performance වැඩි කරන්න read replicas use කරන්න පුළුවන්. Reading වලට priority දෙනවා. එතකොට read replicas. Writing වලට අපි main instance එක තියාගන්නවා. ඒකට write කරලා asynchronously update කරනවා read replicas ටික. Right, so I will show you how the options in the console in RDS. So now then you will have a better understanding. So this is the service, Aurora RDS. Here there are options like this is the quick create option. So if we create this one, by default it will put some services and all. So you can create this one. But I will go into this full configuration option to see what are the options we have. So database engine, it supports Aurora, MySQL, Aurora PostgreSQL, MySQL and traditional PostgreSQL, MariaDB, Oracle, MS Server, and IBM DB2, right? And you can either test or production. Let's keep this production as well. I will select, let's say, MySQL here, since it's the most familiar one for you guys, as I think. And this is the one I mentioned, the availability zone. So RDS supports multiple availability zones. So there are 3 options you can see. So this is the 3 instance option. So here we have our primary instance in the, let's say, availability zone 1. So all the writes happen here. And in other 2 availability zones, we have read replica. So they are readable standby ones. So something happens to here. Users can read from all 3, but we give priority to these 2 to keep the performance up. So even this availability zone 2 goes down, we still have 3 and 1. If this availability zone 1 goes down, one of these will be promoted as the primary instance and still serve the application. So it has an uptime of 99.95. 2 instance, we have one primary instance that is for reading and writing. The second one is standby, so it is not running, but if something happened to this primary instance, this will kick in as the primary instance and it will serve your application. And this option is like a 1 instance option, so only one availability zone. So if something happens, your application will not work. You have to manually spin up another database. So that's why 99.5 uptime, 4.5 down from this option. And then you can select the SQL version you like. So there are a lot of versions supports. And then the most important thing would be the instance type. So if you are running an SQL server in your local machine, it uses the configuration in your machine. But here you have to select what is the configuration of the server that's running your SQL. So CPU's number of RAMs and all. So we have to pay for this as well if you are going with RDS, right? And then what is the storage? So general purpose provisioned IOPS options are there and how much storage you need for the application. And basically these are network configurations. You can keep them as it is. And at the end, you can see the cost, right? So right now with the options I selected, the estimated monthly cost will be almost $400. So if I go here again for our instance, so let's change this to like 2 GB. Minimum is 20 GB. Now it's around 350. It was previously around 400. So I will then again, let's try to increase this significantly. So I will select this 385 GB option. So it's now almost 1600 and 16,500 USD dollars. So RDS is a bit costly. So we have to be careful when you select if you are creating an RDS. Right. The next database, as I mentioned earlier, is the DynamoDB, and this is what I will use in my architecture. Okay, so this is also fully managed database service, and this is the NoSQL offering of the AWS, right? So I think you are familiar with MongoDB. So this is very much similar to that MongoDB key value document model. And unlike SQL, you do not have to know the exact schema. So SQL අපි schema එක දැනගෙන ඉන්න ඕන මුලින්. හැබැයි DynamoDB වල එහෙම නැහැ. අපිට attribute එක පස්සේ add කරන්නත් පුළුවන්, අයින් කරන්නත් පුළුවන්. DynamoDB table එකක සමහර attribute තියෙන්න පුළුවන්, සමහර record වල data නැති. ඒක ප්‍රශ්නයක් නැහැ. And this is highly scalable. කියන්නේ serverless scaling by default support කරනවා, up and down වෙනවා. අපේ usage එක අනුව. And speed, single digit millisecond latency. So if we have designed the application correctly, millisecond latency එකෙන් අපිට data access කරන්න පුළුවන් DynamoDB වල. So it is extremely fast. And on demand and provision capacity. So අපි table එකක් හදනකොට on demand කියන්නේ that's what we pay for our use. So based on our usage, there is a capacity like read capacity and write capacity in a table. By default, it's more than enough. But if we have some critical table that needs to have a large amount of write and or read capacity units, we can provision it customizedly. So අපේ මොකක් හරි table එකක් තියෙනවා නම් අපිට extremely use කරන්න ඕන කියලා හිතෙන, ඒ කියන්නේ මොකක් හරි use කරන්න ඕන හිතන කිව්වට, ඒ කියන්නේ mission critical table එකක් තියෙනවා නම් අපි මේකට read කරන්න priority එක දෙන්න ඕන කියලා හිතෙන අපිට පුළුවන් read units and write units කියනවා මේකට capacity එක provision කරන්න. එතකොට අපි ඒ capacity එක use කරත් නැතත් හැබැයි ඒකට pay කරන්න වෙනවා. Right? Then in DynamoDB there is a concept called global tables. So similar to multi-agent, DynamoDB support global tables, so which means you can access this data from any region. So it's available globally. So data will not be lost until the whole AWS network goes down. And it supports streaming, and there is a built-in caching called DAX. So we can reduce the response time even further if we enable this DAX, but the cost will be a bit higher, right? Okay, so now I will go to here again. And DynamoDB is a service. So I will click here, create table to show the options we have. Create something called feedback. And similar to SQL, when you are creating a DynamoDB table, although it's no SQL, there is a concept called table here as well. You have to define two things, the partition key and the sort key. The sort key is optional, but the partition key, it's mandatory. So after the table is created, you cannot change this. So you have, if this is feedback, I can either use like feedback ID as the partition key and created date as the sort key. So what happens is the value we use for the partition key is the one that we can use to retrieve data without reading the entire table. So for example, let's consider now I'm going to add 3 fields here. Let's say we have feedback ID, user ID, rating, and the created date. So columns feedback ID එක, user ID එක, rating එක and created date. එතකොට මම මේකේ partition key එක විදිහට දැම්මොත් feedback ID කියන එක මට table එකේ specific row එකක් ඕන නම් හැමතිස්සෙම මම use කරන්න ඕන feedback ID කියන එක. මට ඕන නම් හැබැයි මට ඕන user ID එකෙන් data ගන්න මම partition key එකට ඒක දැම්මේ නැති නිසා මට මුළු table එකම read කරලා තමයි data ගන්න වෙන්නේ. මට මොකක් හරි ඕන rating එක 4ක් වෙන feedback ටික ගන්න filter කරන්න පුළුවන්, but behind the scenes මම මුළු table එකම read කරලා තමයි ගන්නෙ. So which is highly ineffective compared to SQL. So SQL නම් අපිට පුළුවන් where clauses දාලා ඕන data ටික විතරක් ගන්න. DynamoDB වල එහෙම කරන්න නම් අපි access pattern කලින් දැනගෙන ඉන්න ඕන අපේ table වල. ඒ කියන්නේ අපි දැනගෙන ඉන්න ඕන table එක හදද්දී අපි මේකේ data access කරන්නේ මොකෙන්ද? ඒක අනුව තමයි අපි මේ partition key එකයි sort key එකයි define කරන්නේ. හැබැයි අපිට පුළුවන් මේ වගේ ඒවා ගොඩක් define කරන්න. අපි ඒකට කියනවා indexes හදනවා කියලා. Right? So I will add let's see ID. අපි තියෙන අපේ හදන table එක මෙන්න මේ indexes එකට එනවා අපි තම table එක provision වෙලා තියෙන්නේ right feedback එක අපිට පුළුවන් GS size කියන්නේ global secondary index හදන්න අනිත් fields වලට. දැන් මම මේ table එක හැදුවේ ID එක partition key එක දාලා sort key එක created at කියන එක දාලා. හැබැයි දැන් හිතන්නකෝ මට requirement එකක් තියෙනවා මට ඕන rating එක අනුව select කරලා ගන්න. එතකොට හැබැයි අපේ feedback table එක කියන්නේ ලොකුට grow වෙන table එකක් record ලක්ෂ ගණනක් තියෙන්න පුළුවන්. මට feedback එක 4 වෙනි ඒවා ටික ගන්න මුළු table එකම read කරන එක ineffective සහ highly cost එකක් යනවා. එතකොට මට කරන්න පුළුවන් මම GSI එකක් හදනවා මේක හිතමු නම අපි we can add a name list rating. එතකොට partition key එක අපි rating කියලා දාලා අපිට තව index එකක් හදන්න පුළුවන්. Then if I need to extract the records based on the rating, it will only provide me the records that have the rating I need, not scanning the whole table. So in DynamoDB, it's a big no. If we have a growing table, we are never scanning the whole table. So we should always use access pattern to access table if it is a growing table. But this index is a copy of the table. So we cannot create indexes as we need. So අපි හදනවා අපිට හදන්න ඕන පළියට අපි indexes ගොඩාක් හදන්නෙත් නැහැ. මොකද මේක copy එකක් අපේ table එකේ. ඒකට අපි copies උත් තියාගන්න අපි same data එකේ copy එකක් තමයි තියාගන්න index එකක් හදනවා කියලා. ඒක නිසා අපි බලන්න ඕන අපේ ටේබල් එක grow වෙන ටේබල් එකක්ද, ටේබල් එකේ data limit එක කොච්චරක් වගේ එනවද කියන තීරණත් එක්ක තමයි අපි decide කරන්නේ අපි ටේබල් එක scan එකක් යනවද නැත්නම් index එකක් හදනවද. But if it is growing table, it's a big no to have a scan operation. So it will cost you later and the cost will be unpredictable as the number of records grow, right? That's a thing you need to keep in your mind. So why choose DynamoDB over RDS? So with the things we discussed, so it's highly scalable and low latency access, and if your data model is non-relational and you cannot be exactly sure of their design, but you should know this access pattern in advance. So like I said, we need to define those indexes. And for Go RDS, if you need SQL, you have a defined schema, you need strong consistency, you can go with RDS. So in our application, I selected the DynamoDB because I thought like we will be need a highly scalable one. And sometimes these fields can change, the feedback field. So PDF එක format එකක් තියෙන්න පුළුවන්, user submit කරන audio වල වෙන වෙන data තියෙන්න පුළුවන්. Since we are extracting this from AI, the schema can change. And I have a few limited access patterns. So either I can access data based on the event, user, or the rating, something like that. So with all these reasons, I selected DynamoDB. So in our application, so whenever user upload the PDF or image or anything, we will analyze it through using Lambda and save these data. Sorry, these text are not, sorry, these text fields are not clear here, correct here. So I will store the data in the DynamoDB, and whenever the event company need to access them, we can go through a Lambda and access those data to the user. So in the architecture diagram, so this is how it will happen. So sign in, Cognito API gateway, and the Lambda. So user can upload file to the S3, and then we are triggering this processing Lambda based on the file upload. So this Lambda then will read the S3 file and do whatever processing required using any other services and save the data in the DynamoDB. Also, whenever user need to read the data, we can either use another Lambda or it will access the DynamoDB table and return the data to the user. So that's how this flow will happen with DynamoDB, right? Okay, any questions, guys, with DynamoDB? Okay, so we are almost into the last 30 minutes. So I will like go through these services very quickly. S3, SNS and SQS. Yeah, so I will first, SNS is the notification service provided by AWS. So it's a simple notification service, SNS. So it supports this publisher subscribe model. So we can create a topic or the maybe like email topic or something, and whoever subscribe to that topic will get the notification. And it has this fan out messaging. So from one, you can send it to multiple recipients like emails, SMS, Lambda functions, queues. So from one place to many. And it supports email, SMS, HTTP, delivery protocols like that. So in our application, once I thought of using SNS to inform the event company or the users that upload the feedback, saying that their feedback is analyzed or the reports are ready for the event committee. So for example, if 100 users are uploading their feedback and all, no, let's take one user. So I am uploading an audio file or something with my feedback. So we cannot keep the user waiting in application so that, okay, your analysis has completed and your feedback has saved. So because it will take some time. So we can do it asynchronously. And once the analysis is complete, we can send a message to user through an email or an SMS or Slack notification or anything saying, okay, your work has been completed. So to do that, we will be creating a topic saying that feedback completion topic. I will show you in this SNS here. So there is something called topic. So this is the topic we are using, and whoever subscribe to this, so we can create subscription. So here we select the process, topic, and either we need to send an email or an SMS or HTTP request like that. So if I select email and put my email here and create, when we put a message to that topic, I will receive that. So likewise, we can, large number of users can subscribe to one topic. So they will all get the notification when it's completed, right? So yeah, it's like that. In our architecture, so I have placed the SNS service here. So whenever the processing is complete, we are informing the user. So this can be the user who upload the file or the event company owners that needs to see if some analysis is completed. Okay, next is the SQS part. So previously I mentioned that processing audio file can take a significant time. Since we are using Lambda, it should be below than 15 minutes, but still we cannot keep users waiting until the analysis happen. Otherwise, they won't be using the application to upload, right? So if we click the upload button and it will keep circling like for 5 minutes, we will be not using the application, right? So in such situations, SQS is mainly used for decoupling. So, which means to make something asynchronous, we can use SQS. So, not only limited for this situation. So, if there is anything in the applications you are designing that you do not need to keep user waiting and you can do it background, you can easily use paste it in SQS and decouple the solution. So, user will get the feedback and the message will be, yeah, I will get here with the architecture. Yeah, so in our situation, I have placed the SQS queue between this Lambda and S3. So give me a minute, I will draw this drawing board. I will open it. You guys can see my drawing board, right? Okay. So let's take a small example here to see how SQS works. So let's assume now user is sending a request, right? And this requires we to analyze our the file user uploading using AWS Bedrock or Extract or anything. So it will take some time. So we can either completely do that in this Lambda and keep user waiting like for 5 minutes and give a response to user, okay, now it is complete. So it is not very user friendly. That's it. But what we can do instead of that is we place this SQS queue behind this Lambda, and once the user upload the file and Lambda reads it, we say, okay, we received the file, we will analyze it. And we are dropping the message to our SQS queue. And then we have another Lambda function that is responsible for consuming this message. So this is the publisher and this is the consumer. So this will consume the message in the background. And once it's completed, we can use SNS or something to inform user, okay, your analysis part is complete. So that's the uses of SQS. So mainly for decoupling your application requirements, right? So if we take the SQS, what we feed in our application workflow, so we are uploading file and the processing job is created, and we queue that processing job in here, and our consumer consume that message in the background and inform the user. So basically, we are using for decoupling our S3 bucket from the processing Lambda. So without the queue also, we can do this in our case. So in our application, we can, if you saw my previous images, I have directly connected this S3 to Lambda. It will work, but we cannot control number of files uploaded to our S3 bucket at once. So There can be thousands or 100,000. So S3, if the users do that, our all Lambda resources can be exhausted from serving this S3 bucket. So S3 bucket එකට එකපාරට images 10,000 වගේ upload වුණොත් මේක highly scalable නිසා Lambda ටික scale වෙනවා. අපේ account එකේ තියෙන provision define කරලා තියෙන provision throughput එක ඔක්කොම capacity එක යන්න පුළුවන් S3 bucket එකෙන් upload කරන එකට. So අන්න ඒක නවත්තන්න තමයි අපි SQS එක මම මෙතන place කරලා තියෙන්නේ. So SQS will process the message in order. So we have a control over how many Lambda functions we are scaling for our S3 image upload. So unless this will have a burst and Lambda function will highly scale and resources and throttling, there can be a lot of issues like that. All right. So the features, it's a queue. So we are queuing message one behind one and mainly used for decoupling. And there are two options like standard and FIFO. So first in, first out, it's order. And the standard one, there is no one order. And the FIFO, we will only deliver one message at once. And the standard, the message will deliver at least once. So aniwa ring kaparak, but more than once, you can also deliver that. And it's highly scalable. Right? Okay, the final service, which is the Bedrock. So this is the AI service provided by AWS. So there are like various foundation models available for you, and it is fully managed. You can select agents and ask questions, create knowledge base, RAG models, anything, right? So I will go to the knowledge base Bedrock bit and show you so later. And in our case, I'm planning to use AWS Bedrock to analyze any details that users feedback message, because different users can express their feedback in different ways, right? So voice messages can have different formats. The PDF or something can have different formats and different wordings. So we cannot write a code to match all these situations, right? So what we can easily do is we can extract the content using extract or transcribe service like that, and then provide this service to an agent, basically a model like ChatGPT, and it will we can instruct that agent to analyze these input we are providing and format the output in the format we need to save in the database and provide it. අපිට ඕන ෆෝමැට් එකකට මේ ටික ෆෝමැට් කරලා දෙන්න කියන්න පුළුවන්. chat gpt එක කරන්නේ අපි ඔයාලා යූස් කරන්න ඇතිනේ. ඒ වගේම අපිට ඕන දෙයක් කරන්න agent level define කරන්න පුළුවන්, right? So I will go to the Bedrock. So Bedrock provide various models for us. So Claude, Anthropic Claude 4.5 offers Haiku. Almost all the latest available Haiku models are here, and there are several AWS provided models as well. These available models can change based on the account limitations you have. So there are some OpenAI models as well, which is not available in this account. So mainly you can use this Claude Sonnet or anything. And AWS Bedrock also supports this knowledge bases, so which means you can create your own custom knowledge base. So if you are studying for exam or something, and what you usually do is you upload the file to ChatGPT and ask the questions from that one. So instead of that, you can create a knowledge base and upload your lecture notes to that and connect an agent to that. And you can ask questions from that agent. So his answers are depend on your exact knowledge, exact notes. So you will get the exact answer you need from there. So I will check and go to here agents to create an agent. Create a quick agent here. So here you can select the agent like Anthropic Claude anything. So I will just select Haiku 4.4 here. So it can analyze text and images. If you need, you can create, likewise, I said the knowledge base here as well. So which means your own RAG model. So it will contain the customized knowledge you have in addition to the agent's knowledge. I will just test this one. Instruction. So let's say agent. So likewise, you chat with ChatGPT, you can chat here. So what you do here, you can do it in your own application as well. So instead of typing here, you can create your own chatbot that answers the question from your own knowledge. So in our application, what Bedrock will do is it will analyze the message or the text or the audio, everything, the content, and it will provide you an defined output to save in the DynamoDB. Right. So final, our architecture will look like something like this. So we have the user and logs into the Cognito through API gateway. And also user upload the file to the S3. And once some file is uploaded to S3, it will put into the SQS queue, and this processing lambda will consume it, and it will use extract, transcribe to get the data based on the format and provide it to Bedrock. And Bedrock will analyze the content and give us the metadata result we need to store in the DynamoDB. So once this processing complete, we can inform the user, and user can retrieve it through this flow from the DynamoDB. So it's like 7 to 8 services. I think this is the minimum services we need to implement. So so that's the architecture I have designed for you guys to explain this AWS basic services. So yeah, now the thing is, I showed you guys how we can create these services through console, right? But assume that you are a group of 5 that's working. So 5 of you guys need to do this exact changes in the AWS console to create these resources. And then you are deploying it somewhere, maybe test environment or production. You have to create those resources in those 2 environments as well. And you have to do some modification for any resources, like enabling encryption in S3 bucket or versioning in S3 bucket. Then you have to find all these resources in the console and do the changes manually again. So it's good. It's okay for one environment, but when the number of environment grows, this using the console to create the resource is not an option, right? So that's where something called IAC, infrastructure as code options, comes in, right? So if you are working with an AWS application, I highly recommend you to follow this infrastructure as code option. So what you can do here is, instead of creating resources through the console, you can do it with the code, a language you are familiar with. So if we take options, AWS Amplify, AWS CDK, Terraform, these are the options we have. So Amplify and CDK are limited to AWS, Terraform is not. So using these 3 services, you can create the resources I explained earlier using a code. So I think you got a GitHub link from me as well. So I have already created this example for you guys. So here, if you guys, you can also clone this one and use it up yourself as well this stack. So I will go first for this auth stack. So here I explained to you in the console. I explained to you in the console that when you're creating user pool, you can create the name and what are the signing options, if the email is auto verifying or not, and what are the attributes you need when you are doing the login, and the password policy. In the console, I showed you like how you can configure this. So with these few 5 lines, you can configure it through the code as well. Then the recovery options and the application you need. So when you run this code in 10 machines, all the 10 machines will get the same user pool, right? Same configuration. The name will change because based on the staging name, you cannot create one with same similar names. So the name you have to change, but the configuration will stay same. So just in case you need to upload the password policy for 10, you can change it here and redeploy. It will deploy in the all the environment. So similarly compute. So here I have created a Lambda function. So a name, runtime Node.js, ARM architecture, memory size, and how long the Lambda function will run. So I have here included 900 seconds, which is whole 15 minutes. This can be like 10, 30 seconds. Then that will be the maximum duration this Lambda function will run. And also login details, tracing. You can do it through the code. Right? Data stack as well. So this is how you can create a table. So you can import AWS CDK and the table name, the partition keys I explained earlier, and recovery options, encryption options, the secondary indexes. All you can configure this through the code, right? Okay, so I have created several scripts as well for you guys to test this. So you can deploy this with this command. So, but you should have AWS account and it should be connected to your development environment using AWS configure and network. So you can deploy this with npm run deploy dev. So I have already deployed it, I think. So I will not do it that deployment again, but I will show you how this will run without this test script. So first it will sign up a user. So since I already have a user, it is continuing. And this is a file I have hard coded to upload. So it's a sample feedback. So it is uploaded to S3. And now it's uploaded successfully. Now it's analyzing. So since a text document, it will go to text track and analyze the text and give to Bedrock, and we will get an output. So this is the summary of this status. So overall feedback is positive with the event being well organized likewise. And what are the key insights and what are the action items we got from that feedback. So this is the format I asked for the agent to return. Yeah, so like that, we can easily create this now with the help of Claude, ChatGPT and all. Creating a project like this only take like 30 minutes and so. So I also did this using Claude. So it's pretty much easy because CDK and all, it's a well-known technologies, right? Okay, then so that's what I needed to show, guys. So now it's almost 2 hours me talking nonstop. So I will take some questions if you guys have any questions to from the session related to this. So anything you need to ask about AWS. So if I know, I will answer. If not, you can get back to me through my LinkedIn. So this QR will take me to my LinkedIn account. You can drop a message from there as well. I got a question from Vihanga. When we are using S3 bucket for storing blobs, how the access control works? Is Cognito handle is so? Are we configuring the buckets to only allow from lambdas that we use in the scenario? Okay, so Vihanga, when you are uploading it through an application, we can configure it Cognito to allow the user to upload. So we can define like we are only allowing to read upload. So based on the configuration we define, users can either access it or upload it. there is also you can either make the bucket public for everyone. So for that, you need to define a specific security configuration access policy. So if you do that, anyone will able to read the bucket content regardless of the configuration you have. But if you need to access it through a Lambda function, then it will go through that identity pool I mentioned. So it's like a service to service communication. In that case, the Cognito identity pool will handle that. Right. So basically for application, if you are allowing user to upload file and read all details, it will be handled through Cognito. And also you can generate something called pre-signed URL. So from S3, you can get a URL with a limited lifespan. So maybe hours or days. So until that period, that resource will be accessed for anyone that have the pre-signed URL. So there are options like that, right? Okay. Any other questions? So you can send it me to directly while we are in the call. I think we will have only. Yes, Kaushalya. So are there any services to prevent unnecessary images? There is a service called AWS Guard Duty. So that analysis for virus and all. And also there are models that you can use. So for specific type of files, you can analyze the file and it will block. There are services for AWS for that. Guard duty is mainly for virus and for the specific like violent files, violent image or things like that. There is models. There are models that you can use in AWS not Bedrock. Sorry, I will send the service name. Any other questions? Yes, so the service is Kaushalya Amazon recognition. So it can detect explicit inappropriate image or low value image, so anything like that, and prevent it. Okay, then that's it I have from my end, Varuna and Amanti. So I can stay here if the guys have questions for a few more minutes. Do we need separate VPC or communication in the services? No, that's not a must. If you have strict security network configurations, you can go for that. But unless, no, we do need a separate VPC. This is for I think that question was sent to me directly, so that was for Vihanger. He sent me asking for separate VPC requirements. We do not need that, Vihanger.
Are there any more questions from our participants? Thank you, Mr. Chamir Dolanga, for that insightful and engaging session On behalf of CryptX 2.0 Organizing Committee, I would like to extend my sincere appreciation for sharing your knowledge and experience with us today. Your guidance on designing architectures on AWS will be highly valuable for all participants as they move forward in the hackathon. As we come to the end of today's session, I would like to thank all the participants for taking the time to join and actively engage with this session. A special thank goes to the CryptX crew for their continuous effort in organizing and facilitating this workshop. Dear participants, we hope this workshop has provided you with valuable insights to design and build better solutions. Stay connected for more updates on CryptX 2.0. Thank you and have a good night.